Hi guys, Mr. Roth here. Today we're going to learn how to find the zeros of a higher degree polynomial using the rational roots theorem. What we have here is a cubic polynomial that does not factor by grouping. So in the past we would have needed a calculator in order to identify the zeros and factor it. But now with our powerful new rational roots theorem, we can figure out what the zeros are without a calculator. So let's recall, the rational roots theorem tells us that if this function, this polynomial function, has any rational zeros, then they will be somewhere on a list that's generated by taking the positive and negative factors of the constant and dividing by the positive and negative factors of the leading coefficient. The constant's -6, so its factors are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And the leading coefficient is 1, its factors just plus or minus 1. Okay, well, dividing by plus or minus 1 isn't going to do anything, so we really just have a list of 8 possible zeros here. Now, remember, to find the zeros of a function, we need to factor it. Factoring it means we're going to be dividing out terms of the form x minus c, where hopefully c is a 0. So to test each of these possible zeros and see which ones actually work, we're going to use synthetic division. We'll divide our original function by x minus each of these possible zeros, and if we get a remainder of 0, well, then we know that x minus that number must be a factor. So let's start with positive 1. Remember, this is really like we're dividing by x minus 1. So we put a 1 in our box, and we put the coefficients to the right of them, 1, 2, -5, and -6, and we synthetically divide. Bring down our 1, 3, 3, -2, -2, -8. Okay, we did not get a remainder of 0, so clearly x minus 1 is not a factor of this polynomial, so we can cross out positive 1. What about x plus 1? Let's try dividing by x plus 1, which means we're going to put a -1 in our box. 6. Aha! We got a remainder of 0. This tells us that if we take our original function and divide by x plus 1, then we're left with the quotient, x squared plus x minus 6. Now, at this point, can we figure out what the remaining zeros are? Of course we can. X squared plus x minus 6 is a quadratic, and it factors quite nicely into x minus 2 times x plus 3. So this tells us our original function, a third-degree polynomial, could be rewritten completely factored in the form x plus 1, we divided that out, times x minus 2, times x plus 3. Well, if our polynomial function factors to this, now we can look at it and quite clearly see what the zeros are. -1, +2, and -3.